It is my great pleasure to introduce to you Dr. Geeta Bangera, who is currently the Dean of Undergraduate Research at Bellevue College in Washington. She is a Pulse Research Fellow. She is also the Principal Investigator of the CommGen Authentic Research Experiences Grant. She is an Adjunct Professor at Washington State University in Plant Pathology and a inventor and technical consultant at Intellectual Ventures, where she has over 75 patent applications. We are very lucky to have her speaking with us today.
Thank you, Kim, for that great introduction. Today we're going to talk about CommGen, the Community College Genomics Research Initiative. The idea behind CommGen is to give students authentic research experiences right in their classroom. This project is supported by funding from the National Science Foundation, a CCLI grant, and a TEWS grant. The genomic library needed for this project was provided by the USDA Agricultural Research Service, and the basic work for this was done at Bellevue College, and this program is now being implemented at about 15 educational institutions throughout Washington State. So why provide authentic research experiences in the classroom? If you look at student athletes, they're willing to spend a lot of time doing things that are not that exciting, but that are related to the game that they're playing. So students will spend hours on the basketball court learning to dribble, or they're willing to put in the effort in the gym to get in shape. Now, suppose we teach basketball the way we teach science or biology. You see in the cartoon here, you have the professor saying, you know, on the board it says what they're going to learn this quarter, and it's all theoretical. They're talking about it in the classroom, and the student says, well, when do we get to play the game? And the professor says, when you join the NBA. This is pretty much true for all science students. They only get to do the science once they are professionals in the field. This is the reality of biology students today, and it's not that different from 100 years ago. So how do we fix this problem? We let them play the game. Let's bring the students into the lab, or better yet, let's bring the lab to the students and provide them with those authentic research experiences right throughout their academic careers, thereby getting them engaged in the science early on. Today we're going to talk about take all, wheat, and the genetics of Pseudomonas fluorescens. And as is the nature of science, we can already say that we have to change the slide to say, instead of saying fluorescence, we have to call it Brassicacearum probably, because of the research that's already been conducted by students in the CommGen project. This is a collaboration between Dr. David Weller and Dr. Linda Tomashow of the USDA Agricultural Research Service, Root Disease and Biological Control Unit, which is located within the Washington State University campus, and Bellevue College. The USDA Agricultural Research Service is the largest research agency in the US, and they are spread nationwide. And the way that the system works is they have independent research labs in some cases, but in other cases they're embedded within research universities. And in this case, the Root Disease and Biological Control Unit is embedded within Washington State University and its campus in Pullman, Washington. The current research happens in the Vogel Plant Biosciences building with its state-of-the-art lab facilities overlooking Martin Stadium. I like to stop at this slide and talk a little bit through the process of doing science and what it means to be a scientist. So one of the things you might notice about the names on the slide is that these are names from all over the world. You see Dmitry Mavrodi and Olga Mavrodi are originally from Russia. You have Dalsu Kim, who came from Korea. I am in this list, as well as Jos Rijmakers, who came from the Netherlands. Blanca Landa came from Spain, and she's back in Spain now as the Assistant Director of the Center for Sustainable Agriculture. This is a key part of being a scientist. because you become part of this international family of scientists who are forever in your network, and you continue to work with them throughout your professional career. Science is a collaborative process that is very social, in that there's a lot of social interaction involved in science, and a lot of people outside of science may not necessarily know this. When we go to conferences, this is one of the key things we look forward to, is meeting our old friends and collaborators and interacting with them and coming up with new collaborative projects, or just to sit around and have a glass of wine and enjoy each other's company. So now we'll get into the technical aspects of the research project that you are about to embark on. As you know, agriculture is a key component of any state's economy, and that's true for Washington State as well. On the West Coast here, we have the tulips, we have cranberries, and we have some forestry and maybe some ranching. As you go over the mountains to the Columbia Basin area, you of course have the wineries and you have apples. Now, all of the agriculture that happens in this part of the state, of course, is dependent on water from the Columbia River and the dams that are built across it. As you move further east towards the Idaho border, you come to the Palouse with its rolling hills and the wheat fields that cover those hills. This is the area that we're going to talk about, because the research project that you're involved in involves the wheat crop. The Pacific Northwest is the third largest wheat producer in the country. The soil across the Palouse is almost as good as gold, because it's the most productive wheat growing area in the world. What is grown is mostly soft white wheat, which is exported to Asian markets for making noodles and cakes. Some farmers also grow what's called hard red wheat, which is used for bread. A key part to remember here is that large areas of the Columbia Basin are irrigated, and that changes the dynamic of the disease that we're going to talk about. Now, wheat used to be grown in the western part of the state, where on the other side, on our side of the mountain, but they've gone away from that in the last 30 years, and the main reason for that is the disease that we're going to talk about. So why is this critical? So if we go back to the previous slide, you see the rolling hills in eastern Washington. And we talked about the fact that there are miles and miles of this crop. Anytime you grow the crop for miles and miles, that process is known as monoculture. And monoculture is a very efficient way to grow any crop. So whether you're growing oranges in Florida, or corn in the Midwest, or wheat in eastern Washington, it's a very efficient way to produce large quantities of any kind of food. But it comes with its own problem. Basically, anytime you do monoculture, you're setting up a buffet for anything like that likes to grow on it, on a crop, in a crop, or eat that crop. So that creates a problem that every farmer deals with. It doesn't matter what the crop is. This is an issue, and that is the issue of disease. Every crop has its Achilles heel. Some crops are affected at the leaves more, but in the case of wheat, the Achilles heel, the part that is most vulnerable, is the root. And as you can see on this slide, you can have 3 different diseases that sort of form a complex that affect the root of wheat crops.